Hello, today we'll be proving the quotient rule for derivatives. So before we start, the notation I'll be using, the derivative of f of x is f apostrophe x. F of x means take the limit h going to 0 of f x plus h minus f of x divided by h. This is saying as the difference between x plus h and x goes to 0, the slope will approach a certain value. This is just a slope formula, condensed. I will also be using d of x. I've used that in other videos, but I don't think I will be using it today. So let's start off. So we want to take the quotient of two functions. So what we can do is we can write out the limit as this. F of x plus h divided by g of x plus h minus f of x divided by g of x, all divided by h. And then we can remove these denominators by moving them to the bottom. And then we can distribute and make it all one numerator over one denominator. So what I did was I just multiplied this side by g of x, this side by g of x plus h. And I got this. F of x plus h times g of x minus f of x times g of x plus h. And that's all divided by h times g times x plus h times g of x. That's a bit of a mouthful, but we'll condense this. So now what we're going to do a bit of algebra. We're going to add our values by g of x times f of x, and we're going to subtract as well, so we're just adding 0, so this doesn't break any equality theorems or laws. Now what we can do is we can factor out the g of x on this side, and we can factor out the f of x on this side, so we have two separate functions just all under one denominator. G of x times f of x plus h minus f of x minus the same thing, except it's f is now on the outside, g is on the inside, and the denominator stays the same. And now what we can do is we can separate the two functions. We can move our h back up, distribute it among these two, and then keep them like this. You notice now that we have everything except the limit part for a limit function on these two, and these four are just regular functions. When h goes to 0, this will just become g of x. And what we can do is we can move the limit out for each of these. Now you have g of x times taking the derivative of f plus h minus f of h times taking the derivative of g of x. Notice over here I gave the limit function as a recap, and then this is all divided by g of x squared because it's multiplied by itself. And this results in g of x times the derivative of f of x minus f of x times the derivative of g of x divided by g of x squared. And we cannot factor this out, even though there's a g of x here and a g of x squared here, because this is the derivative of g of x. Okay, time for a quick recap. We start out by writing out the function like this. We simplify it, so there's just one numerator and one denominator instead of like numerators and denominators and numerators. We add and subtract f of x times g of x in the numerator to make sure we're just adding 0. We then factor g of x from the first half and f of x from the second half. We figure out that each of these small bits are derivative functions without the limit, but we can move the limit over there and take these parts out of the limit. That's why this g of x got changed to this instead of being g of x plus h, because h became 0 as we moved the limit. And finally, we just rewrite it so it's much more compact. We have g of x times f derivative of h, derivative of f of x minus f of x times the derivative of g of x divided by g of x squared. Okay, I hope you enjoyed. I hope you figured out how you can how this quotient rule works. This will work for if you have 1 over of certain function, because you can just make the f of x 1, and you can take the derivative accordingly. The derivative of a constant is always going to be 0, so that will it will be fine to take the quotient. Okay, please send this to anyone if they need help with quotients, and I'll see you soon.